Hi, it's Mrs. Pope, and today we're going to talk about logarithms. What an exciting topic! We refer to these as logs, so you won't see me writing that long word anymore. Our goal today is to evaluate and graph log functions. The key concept here, log with base b. This is the definition. Log base b of x equals y. That's how we read it. If and only if b to the y equals x. So I've written them in these colors so you can see b is always the base and x is the main number. Y is the exponent. So for example, if log base 3 of 27 is equal to y, then you automatically know 3 to the power of y is equal to 27. So the base to the power of the answer is equal to the big number. Keep that in mind. Base to the power of the answer is equal to the big number. Okay, so example 1, write each equation in exponential form. So log base 2 of 8 equals 3. So log base 2 of 8 equals 3. That means 2, sorry, I changed colors a little bit, 2 to the power of 3 is equal to 8. Base to the power of the answer is equal to the big number. So log base 4 of 1 over 256 is equal to negative 2. That means 4, so the base to the power of the answer, so to the power of negative 4, is equal to 1 over 256. And that makes sense because if you have a negative exponent, it's 1 over 4 to the positive 4, which would be 256. And last but not least, log base 3 of 729 equals 6. That means 3 to the power of 6 is equal to 729. And we'll talk a little bit more about what logs are, but logs are the inverses of exponential functions. So they help us get exponents out from where they are and solve. And we'll look at that a little bit more in detail. So example 2, write each equation in log form. Now we want to go the other way. We wrote them in exponential form, now we want to write in log form. So we have 15 to the power of 3 is equal to 375. What if we want to write this in log form? Well, that means log base 15 is equal to 3375. Nope, say that again. Log base 15 of 3375, that's what I meant to say, is equal to 3. And check, 15 to the power of 3 equals 3375. That's what we have. So I think you get it with the colors, hopefully. So here, log base 4 of 1/2, right there, log base 4, look, now I need the colors, forget it with you, log base 4 of 2 equals 1/2. Alright, so 4 to the 1/2 is equal to 2, and that's true because the square root of 4 is 2. Alright, so here, log base 125 of 5 is equal to 1/3. All right, now let's evaluate log expressions. So now we want to figure out what this actually is. Log 16 of 4. Well, what that means is 16 raised to what power is going to give me 4? So the first thing we want to do is set it equal to y. Once we set it equal to y, let's use the definition of logs. So 16 to the y is equal to 4. 16 to the y is equal to 4. And so here we can do a little trick. It's changing the base of this. So what we're going to do is put 16 in base 4, and I'll explain what that means. So this is really like 4 to the 1. If I could turn this into base 4, I would have the same base and I could equate the exponents, and that would make it easy for me to figure out what y is. And I can turn this into base 4. So 16, if you agree with me, is the same as 4 squared. 4 squared is 16. So this is really 4 squared to the y is equal to 4 to the 1. Now, power of power tells us this will be 4 to the 2y is equal to 4 to the 1. So this was power of power. Those are our rules from before. And now we can use our other rule that we can set exponents equal. So if you have the same base, you can set the exponents equal to each other. So 2y is going to be equal to 1. Divide by 2, y is equal to 1/2. So this evaluated means 16 raised to the half, which would mean the square root, is 4. And that is indeed correct. So 16, what did it say? Log base 16 of 4 is equal to 1/2. Now we've evaluated it. All right, key concept. Now we're going to graph. Last few examples, we're just going to be graphing. This is kind of cool. F of x equals log base b of x. There's two different scenarios of what your graph might look like. If your b is greater than 1, it's going to look like this. It's going to increase and go to the right. If your b is between 0 and 1, so it's a fraction, it's going to go down. That's the shape of the graph. It's not going to change. Doesn't matter. Our domain, range, and asymptotes are the same. Our domain are all real positive numbers. That means our x's are all real positive numbers. Our ranges, look, they range all real numbers. They can go negative or positive. And our asymptote is the y-axis. This graph never crosses the y-axis, and neither does this one. So knowing that, we have 3 points that are automatically there. B1, 1, 0, and 1 over b, negative 1. Notice these points are exactly the same on both graphs. It just depends if your graph is going this way or if it's going this way, which is based on what your b value is. So let's look at 2 examples for each type. So if we're going to graph log base 5 of x, we want to identify b. Well, b is 5. And so since b is greater than 1, that tells us what shape we're going to be looking at. So b is greater than 1. We know it's what the shape is going to look like. And now we can use those points. Since our points are 1 over b, negative 1, 1, 0, and b, 1. So let's write those. 1 over b, negative 1, 1, 0, and b, 1. These are our 3 points. Plot them, connect them. So if I have 1/5 negative 1, you can figure out about 1/5. You know, it's less than a half. So let's go 1/5 negative 1 right here. And let's go 1, 0. And then 5. 1, 2, 3, 4, 5, 1. I already know what the shape is going to look like. So there's my graph. Make sure it does not cross over the y-axis. All right, let's look at one more graphing example. Let's graph y equals log base 1/3 of x. So we see that 1/3, our b is 1/3, and since it's between 0 and 1, we know that the graph is going to be coming down this way. So we can still use our points, b1, 1, 0, and 1 over b, negative 1. So we have 1/3, 1, 1, 0. And careful here, we have 1 over 1/3. If you remember, when we divide by a fraction, we flip, take its reciprocal. So this would really be 3 over 1 times 1, which would just be 3. So this point is actually 3, negative 1. So let's plot our points. 1/3, 1. 1/3's about there. Let's say 1 right here. 1, 0. And 3, negative 1. 1, 2, 3, negative 1. We already knew the general shape. Pass through these points and make sure you put them on here. I don't think I did on the last one. 1/3, 1, 1, 0, and 3, negative 1. Make sure you label your points on your graph. Thanks for watching, and I hope you enjoyed. Remember, you are responsible for your own learning.